Shown here is the graph modelled by J.J. Sapkowski Jr. representing the diversification and mass extinctions of evolutionary faunas. It shows how many families of marine organisms there have been as a function of time. The Ordovician period was from 510 to 438 million years ago. At this time, life was believed to be confined to the marine environments. The steep rise in marine families on the Sapkowski graph indicates the GOBE, the Great Ordovician Biodiversification Event, also known as the Ordovician radiation. During the GOBE, an estimated growth in the amount of marine families from around 120 to 480 occurred in just over 25 million years. There was a greenhouse climate at this time which promoted diversification through large-scale ecosystems and abundant nutrient supply. Late Ordovician ecosystems consisted of Cambrian, Phanerozoic and modern fauna, with the Phanerozoic being predominant. Organisms such as cephalopods, conodonts, bryozoans, crinoids, graptolites, brachiopods and gastropods underwent major evolutionary radiation. Nautiloids like Orthoceras were one of the largest predators in the Ordovician. Straight-shelled nautiloids ranged in size from a few centimetres to metres in length, although they were likely to have been relatively small at this period.
After the GOB, continued cooling eventually resulted in the onset of a short ice age known as the Extinction. Sea levels fell by 45 to 65 metres at this time, the cause of which was thought to be down to the weathering of the Caledonian Mountains and thermohaline circulation. Volcanic activity resulted in sulfates entering the upper atmosphere. Glacial maximum lasted less than 1 million years. A large continent known as Gondwana was situated over the South Pole.
Gondwana consisted of the modern-day continents of Africa, South America, Antarctica and Australia. 4 microcontinents known as Laurentia, Avalonia, Baltica and Siberia were separate from Gondwana and at two extremes of an ancient ocean known as the Iapetus. Over the course of the Ordovician, this ocean was closing with volcanic activity occurring due to the subduction of crustal plates. The Appalachian Caledonian orogeny was caused by the northward subduction of the Iapetus Ocean beneath Laurentia. Sulfur ejected from volcanoes as sulfur dioxide and hydrogen sulfide is oxidized to the sulfate ion. In the upper atmosphere, the sulfate aerosols absorb solar radiation and can increase the albedo of the planet, resulting in less of the sun's radiation reaching the Earth's surface. This led to an overall cooling of the planet, leading to the onset of the Hernantian glaciation around 445 million years ago. This is a depiction of the Earth in the Ordovician, with the red marker indicating the approximate position of Cork. During this glaciation, there was growth of an ice cap on the Gondwanan continent. It is possible the ice extended even further. This led to a drop in global sea levels. The glaciation was short-lived, lasting only 0.5 million years. From the Sapkowski graph, it can be seen that the mass extinction lasted for a period of approximately 5 to 10 million years. This occurred in two distinct pulses. The first pulse of extinction was caused by a drop in sea levels due to the trapping of water in continental ice sheets, draining the shelf seas, producing harsh climates in low and mid latitudes. This activated deep ocean circulation, transporting toxic matter from the depths. The lowering of the sea level resulted in a loss of shelf habitats, forcing fauna into deeper water environments.
The end of this glaciation coincided with rise of sea levels and temperature, change in carbon cycling, and widespread anoxia due to stratification of the oceans.
The second pulse of extinction was caused by a melting of the ice caps. Rising sea levels presented a second catastrophic event as fauna which had survived the first pulse encountered a flooding of ecosystems. Again, fauna which could not adapt became extinct. Cessation of thermohaline circulation resulted in the return of anoxic greenhouse oceanic conditions and is thought to be a possible cause of the melting of the ice caps. Brenchley et al. 1989 gave an account of some of the overall losses, including a loss of 75% at genus level of corals and trilobites, 70% of crinoids, and brachiopods were reduced by 25%. House 1988 indicated a loss of nearly 55 out of the 100 or so genera of nautiloids. While a great number of fauna were affected by the extinction event, some notable survivors are the brachiopod Brevilla manella. This originated in Baltica and exploited the Laurentian continent due to terrain accretion. Some straight-shelled nautiloids survived the extinction, most likely owing this to their superior mobility and adaptability as a predator. According to S.C. Finney, biostratigraphic records are particularly excellent through the North Extraordinarius graptolite zone, correlating to the Gondwanan glaciation and late Ordovician mass extinction. Graptolite diversity decreases substantially to 7 species and then 3 species at the base and top, respectively, of the North Extraordinarius zone. The sedimentological record of shallowing is interpreted to signal the eustatic sea level drawdown triggered by Gondwanan glaciation. 2 distinct glaciation events are evident in the sediment record. These deposits are seen in the Ellis Bay Formation, Anticosti Island, Canada, and other deposits indicating sea level fall are seen in Nevada, USA. K-bentonite ash deposits are present in Northern Europe and the east of North America. These deposits are evidence of one of the largest volcanic eruptions in the Phanerozoic. Above the K-bentonite beds, sampling of conodonts in sediment layers show a major but short-lived cooling of the sea. Strontium levels increase in the sediments due to more intense weathering of continental crusts and increased activity on ocean crust due to tectonic plate movements. Organic carbon from the weathering of exposed carbonates is seen in sediments around the time of the Hernantian glaciation.